thanks everyone for joining. My name is John Osborne. I'm a software supply chain architect at ChainGuard. Yeah, has anyone heard of ChainGuard before? Sure. A few people? Okay, so we're only about 50 people. We're largely behind a lot of the software supply chain technologies, frameworks. Has anyone heard of SLSA or Sigstore? Any of those things? So a lot of the founders of ChainGuard are behind those projects, helped get those projects off the ground. I came from Red Hat, and I've been covering the public sector for a while before it went to startup. There's been a lot of noise about software supply chain, so the goal of my talk is to really give you, like, what are the easy wins? Like, what are the easiest things you could do to increase your supply chain security? And, you know, that really don't involve a whole lot of change or anything like that, just quick wins, verifying software, verifying the integrity of the software, and so forth. So, easy win number one, before I actually get into the technology. Verify the binaries that you're downloading. So this was a, I can just drag that over. I'll just There we go. So this was an announcement just this week, but Python, they started signing their software with Sigstore. Sigstore is a free signing service. I'll talk about what it is and how it's used. But this is an easy win for you all, verifying Python. So this would be just installing the Sigstore pip extension. They give the Python on the release notes, they give the certificate that was used, the signature, and the binary, and then just running a command, you can put that in your pipeline, and you know that you're using untampered with software. That's really what signatures guarantee, is that the software hasn't been tampered with since it was signed. You know that you have the exact same binary as when it was signed, you have cryptographic evidence of that. Now, we'll close that. Now, what is software supply chain? Well, there's a lot of definitions out there, but it generally falls into two buckets. One bucket, your code dependencies. I think everyone's familiar with that. Second bucket is really anything interacting with your software. So if you saw like SolarWinds, that was the IDE. Target, that was the HVAC system, right? That's how they came in. Anything interacting with the software. If you live in a classified space, that could be a diode, GitHub, anything that's running security scans, tests, all those things are interactions, and they're part of the software supply chain for your app, meaning that potentially those could be targeted as a way to inject malicious code or otherwise activity into what you're doing. Now, this was a query I ran with BigQuery. Google did a big data analysis, put all the data publicly available, but this was a query that said, what are the dependencies that have critical CVEs and the most number of packages deploying on them? Because we lack a lot of visibility into our transit dependencies. We know what we're using, but we don't necessarily know what those apps are using, right? And there's a lot of things downstream. Some of the studies have been done show that these aren't really even trees at all, dependency trees, they're dependency graphs. So you depend on one piece of software that depends on something else you're already using, but a different version, and things get really complicated. And then the systems that are interacting with the code, we don't really have a lot of tie back. Like if you make a Git commit, yeah, there's a log that you made a Git commit at a certain time, but there's no real cryptographic proof or even information that tells you, even unsigned information that tells you that that Git commit actually was part of your build that got deployed into production, right? There's no tamper verification of an integrity verification of a lot of the software and pieces in the ecosystem. So this was a quote I loved from the executive order, and it basically just said, transparency equals trust, right? If we can trust our infrastructure, then we can, if we can increase our transparency, then we can increase our trust in our software. So to me, what you want to do is basically you want to create a data layer of software supply chain information. So it's a lot of metadata about the things that you're using. So this would be, first piece is digital signatures. So if you look at a lot of the frameworks that are out there, there's software supply chain specific frameworks like NIST SSDF, there's CIS benchmarks that just came out with one, SLSA. There's also tangential, like general purpose security frameworks that are now incorporating a lot of security pieces in it. So that would be like the PCI, for instance, had a lot of announcements recently around supply chain. And what you want to do is be signing the software that you're bringing in, verifying software that's signed with third-party dependencies. Every time your artifact gets interacted with as it goes to prod, you want to have nice handoffs. You want to know that something hasn't been tampered with in the middle. And that's really what attestations are about. Basically, they're just declarations of your software. It's really just a JSON document that says things in a structured way. So it might say, I did a 2-peer review, I put a Git commit inside this image, I did a security scan. It's just a structured JSON way to say that. You sign it, and you can attach it to the artifacts. And then SBOMs. So there's two main formats out there. CycloneDX and SPDX. A lot of tools will actually generate these for you, and you want to sign those also to make sure that your SBOM hasn't been tampered with. So SigStore is really one of the most foundational pieces to this, and the idea behind SigStore is that developers will do things if they can increase the security of their app, and it's not like a big lift, right? It's got to be easy. There's a whole list of technologies that have been out there for years, and they're great technologies, but they're not easy, right? So they ultimately don't get a ton of adoption. So SigStore is designed to make signing software easy, and a lot of it's based around key automation. So there's a public instance of SigStore out there now that a lot of open source developers are already using. It's got 3.5 million entries in it-ish, and it's run, you've seen this command inside release notes now, cosign. Cosign is the piece that actually signs that software. Now the idea behind this is you don't have to care about the keys at all. You basically just sign in with your Google account, your GitHub account, whatever you have, and SigStore issues you a certificate that's good for 10 minutes. It lives in memory, it just goes away. And then the integrity lives on through what's called the transparency log. If you don't understand what I'm saying yet, I'll show you some specific examples. But again, the idea is that this is very easy. So if I'm signing my software, all I need to do is like cosign sign and give it an image. It'll sign the image for me. It'll store the image inside of a container registry repo also. There's a kind of interesting little naming convention it uses. But if you sign a container image, it'll basically just take the hash of your image and then add .sig to it, and it'll put that inside of your OCI registry, container registry. Same thing with an attestation. If you sign an attestation or SBOM, it'll actually live inside your container registry with this kind of naming convention that points to the image. I can show you what that looks like. So, easy win demo number one, signing and verifying images. That's very easy to do. So let me bring up my browser here. Mouse back. Log in here real quick. This is my Gmail account, my Google Cloud account, and it needs my AV key. We just got our SOC 2, which is exciting, but constantly signing things, constantly using my AV key. Fast enough. Let's try to get back. Be quick with these keys. Okay. First thing I'll do, I'm just going to turn this around so you can see this. show you what this looks like inside a registry, and then I can actually sign an image for you. So this is the Google container registry, but this could be any registry. I just like this one because the UI is very pretty, and it shows you very clearly what things are. So when I go to sign things, the signature, the attestation, everything I'm signing can live in this registry, and that's very convenient just for artifact storage purposes. You can sign anything with Sigstore. We've had people reach out to us about signing apps that are 30 years old, signing binary files, signing assembly code, all sorts of things. And that's all valid to do, but again, if you do that, if you sign non-container images, you just have to keep track of the signature, you have to keep track of the certificate, those types of things, whereas if you sign a container image, which is kind of very nice, and some software now actually ships everything as a container image, which is very cool. Zoom out here. My busy box image. Oh, right here. Yep. So if you see this hash right here, I'll click in it so you can see it. And the hash associated with this image is D83. It's in D83. If I go back, getting cropped out of the browser here. Let me zoom in. Very nice. You can see. Very happy. So if you see, and I'll zoom in so everyone can see this as much as they can, but the way it stored it in the image was it actually just took that hash that ended in A3, it added .sig for the signature. That's the signature of the SBOM, or of the container. So if I clicked in here, this is all standard OCI stuff. So it's actually put the certificate in here, the chain in there, and the bundle. So if you wanted to go prove that this was potentially untampered with, you could just, that's just all done for you by the tooling. You don't necessarily have to know or care about that. And same with the attestation. So again, the attestation could be anything. You can sign it. A lot of times you're just kind of signing these JSON documents. One of the common use cases now is signing Trivy scans. And so, should I even generate a new one? Let's move this over. I want to sign something. Stuck in no man's land here. I'm just gonna mirror my screen, so that'll be easier. Okay, very good. So, signing things is very easy. I can just, you saw the container image, but if I want to sign, for instance, just a file, like I have just an empty file here, I can just type cosine sign blob, and what's going to happen is, sorry, we're in a, normally work on the workstations. Okay, so for the flow here, it's going to pop up, so it's going to sign something for me, right? But if you think about the way modern cloud works, you kind of work from things that were really static on-prem, right? Like IP addresses, firewalls, those types of things. It's more identity-based. right? Like attaching role-based access control to whether it be groups or users in the cloud. So it's not really about the IP address anymore, it's really about the identity. Well, if you think about modern key signing, it's actually very similar. It's a lot about the identity management of it, and less about the key. So if you actually have to look at a private key, we're probably doing something wrong. We want this to all be transparent for you. So the way this is all done is with OIDC. So if I log in with my account here, this is the public 6-door instance, so you can run this also. All I'm going to do is log in. And when I come back here, it signed it for me, and it created this entry. So this entry is in the public domain. So let's go take a look at that. 349. So there's a web interface here. Verifying the command line might be better, because I don't have the web address. Okay, so we want to verify it later. We can just use the command line. And you're going to see the certificate information is going to be in there. It's only good for 10 minutes. Oh, I'll have to install that after. It's only good for 10 minutes. Let's see. Sorry, it didn't keep my, oh, you know what? I'm logged in as a different Google user. Let me just switch to my other profile. It's all bookmarked. I'll come back to that one. We'll just go back to that one.
What the idea is that this is all automated and very easy. So
automation is really critical because if you look at the way things are done, I'll pull this up and I'll put the link at the end. Now we need to sign everything and verify it through different handoffs, right? So ultimately, what does that give us? It tells us that things haven't been tampered with. And it can tell us that in non-repudiation, it knows that we signed it because it's cryptographic evidence. So what are we signing? Well, the first thing we sign is SBOMs in artifacts. So SBOMs are becoming increasingly a topic of conversation, but I think there's still a lot of work to be done to making them really usable. Is anyone using SBOMs yet, or is it mostly just kind of conversation? A few people. So I look at it almost a little bit like Linux and Solaris, right? Like there were things that you could do in Solaris that you still couldn't do in Linux like 2 years ago, right? But it hasn't really been anyone's investment for a long time. Well, SBOMs are kind of that way to me. It's very early on. This is where the investment's going. But ultimately, I think everyone will benefit because what they'll end up providing in the end is an open way to declare your dependencies. If you think about the way this is done now, it's a lot of SCA tooling, it's a lot of big proprietary databases, it's a lot of obscurity to where they get their artifacts. So the SBOMs are an open way to do that. Now, I'm not going to demo this, but I wanted to show you just something in the repo. So a lot of your existing tools will do this for you already. They will generate SBOMs, or there's probably an SBOM tool up there to do this already. So, for instance, and I'll show you one right here. So we're using KO to do a lot of our internal builds. This is a tool to build Google images, but there's plugins now for Python, Java, Maven, et cetera, and a lot of these can build a lot of information, supply chain information for you. So here's KO. This is a GitHub action we use, and it builds an SPDX SBOM for you by default. And you can change it if you want it to be Cyclone DX. That's all built in for you. If you're running Docker right now, it can generate provenance information. If you're using Podman, it can generate provenance information. Now, if you're not familiar with that term, provenance, what it really is simply information about the build. So, was it built with a certain Git commit? Was it built with Was there a security scan done? That's all the provenance information, all the information that goes back to how it was built. And a lot of your existing tools probably released something in the last 6 months that can allow you to generate a lot of that information for you. So typically, oh, here's the link too, but I forgot I put it in my slide. Common attestations. So again, if you look on the internet, I think it's really confusing because there's not a lot of great documentation out there. And we're working to change that at ChainGuard. We're going to release something called ChainGuard Academy, which will be an educational site. But a lot of attestations, what they really are is they're simply just JSON documents. And some things, there's a standardized way to say certain things, like you did a code review. But you might have unstructured ways you're going to do something specific to your organization. You might say we did an engineering review board meeting, whatever it may be, right? We deployed on Friday because the boss was here, I don't know, whatever you want to do. And once you sign it, then you have cryptographic evidence. You can attach that to the artifact, right? So later you can go verify that whatever that process was followed. Now it can get pretty interesting. So security tools, this is something we're building, actually will output into something called Serif now. A lot of them do. Has anyone heard of Serif? So Serif is an OASIS standard, and it's basically a structured way for a lot of these security scanning tools, which everything's also been a one-off, right? So this is a GitHub action that we use internally, and we're basically just taking the output of a Trivy-scan and putting it inside this attestation. So we'll sign this, and then because the output is standardized, we can write queries to have policy around this. So I have a policy that says nothing with a critical CVE is going to come into the environment. And I know there's no critical CVEs because the scanning results have to be attached and signed to the artifact. So this is another one. This was the link I was looking for. So I'll actually go switch back to the thing that we signed. What was the...
So in general, are you storing the results in the repo as a blob as part of the signature, as opposed to storing a link to a result somewhere else?
Yeah, so you can do it a number of ways. Typically, you're signing the container manifest, I think, is what it does by default. I saw that some releases of software, they're just signing the checksum. So they're actually not even signing the artifact at all, they're just signing the checksum. So when you download something, you know that the checksum hasn't been tampered with. So this was the link I was looking for. And so this is just a public web interface to the transparency log. So you can see this was good. This certificate was good for 10 minutes, right? Because I generated it 7 minutes ago. It's good for 3 more minutes. So it just means it's living in memory. A couple other interesting things. One, the key is only used for code signing. So I couldn't use this key and like host a short-term like web server, for instance. And the other interesting thing is that my email address that I picked, if you remember, I picked my ChainGuard email. This is now the alternative name inside the X509 certificate that got generated. So this is what I used to sign my code. If I had created an attestation, the attestation would be shown here also, and I could look at that. Now, when I set policies around what I'm signing, it's not just around what I'm signing, but who is signing it, right? So I can make specific attestations, and I'll say, for instance, that, well, actually, the Python release was a good one, because the person that was signing the Python release code was, so Python's runs Sigstore. There is the release manager. So you do have to know the release manager to sign and verify a Python release, right? But if you're doing something internally, you'll want your build systems to be signing the software. It's not just about people. And so then you can go validate later that something that's deployed in production actually came from the build system and hasn't been tampered with. And I'll show you what I mean about that in a little bit. So if you look at all the frameworks that are out there, Sigstore becomes really critical because you're constantly just signing and verifying things. Whether it's SLSA, you're signing your upstream dependencies, or you're verifying your upstream dependencies that they're using Sigstore to sign their code. NIST, CIS. They want you to sign your Git commits, they want you to sign your compiled binaries, all these things. So it's a lot of signing and verifying. And I highlighted some of these for you, so this was CIS. And you don't have to, this is more of a reference slide, but the idea is like, you're gonna have to sign your SBOMs, you're gonna have to sign your Git commits, you're gonna have to sign your compiled artifacts and all that stuff. And NIST SSDF, very similar. It's constantly you're signing and verifying things because that gives you the integrity chain, right? Because you verify every step of the way, you know that you got something from the person who gave it to you and it hasn't been tampered with. So incremental adoption, I pulled out a specific SLSA example so you can see what I mean. So I like SLSA as a framework because it gives us really an incremental path. So if you're SLSA level 1, a lot of people can get there today. That is scripted builds. Maybe you've signed something, but it's not required at all. Really, this says is that you have documentation. So you know how to build your software. You don't even necessarily have a build system. You can build it on your laptop. It's really just about you have something scripted or documented. Now level 2, that's going to be more stringent. So level 2 says you have a build service, right? So say that's GitHub Actions, say that's Jenkins, etc. Hopefully you're signing your software with a build service, so you know that it came from the build service, but it's not necessarily a requirement. And this is what it would look like. So this is a real life example. So when I sent out these slides, you'll be able to click. These were attestations that somebody else made in the transparency log, so you can see that they made this 3 months ago. And this was, I know this team actually, this is Equinix. Anyone use Equinix? So they do a lot of signing of their software. This is the GitHub SHA that was produced when it was, they signed with the Git commit. And this was the attestation that they created. So they're using SLSA. This was the image that was created, audit tail, and this was the hash of the image. So if I went to the GitHub container registry, that's what GHCR is the GitHub container registry, looked for the hash of this image, well, it's now tracked back to the hash of my Git commit, right? So they're making attestations about the actual source code inside their compiled binaries. So level 3 is a little bit more stringent. It's the same thing, but now you have to sign and verify your software. So you know that you have cryptographic evidence that it came from your software. And you can't really bury keys in your scripts anymore. You need some sort of automation around the key management system, because that's a big entry point too. If you have long-lived keys and stuff, it just increases the attack surface. So 4 is, right now in the SIG store community, level 4 is really hard to achieve. So they're kind of, the gap between 3 and 4 is very big. So there's a lot of talk about maybe having a 3.5 or lowering 4. We're not really sure yet. Those meetings happen quite a bit. But within level 4, there is a requirement to do code reviews, so having a second person check. But this is also a requirement for PCI, a lot of other frameworks that are out there. So what this would look like, so you can turn on, we work with customers that are using like GitHub Enterprise, for instance, and you can enable something in there that says that you have to have 2-peer review. But then there's no real like cryptographic evidence or tie back to the software artifacts that happens, right? So what you can do is you can use SIG store to make that happen. So you can create an attestation. Again, it's just a JSON document, and then you have both people sign it. So you can integrate with GitHub in order to do that. So easy win demo, your build tools may already do this for you. So again, a lot of them create this kind of output attestation stuff that you can use and generate your artifacts. Now, we're integrating with a number of key things here. So I mentioned OCI registries, so that's where cosign is used a lot right now and really integrates a lot with, but also KMS systems. So sometimes customers get pushback around, having short-term certificates, and where is that CA? Well, the CA can be your CA. It can live on-prem, it can do all those things. That's just the public instance, what I'm showing you. But if you already have a key management system, whether you have a crypto team, if you're a large bank, or you have some sort of AWS KMS as an approved solution, or GCP, Azure, all those can be plugged in here also, so you can automate certificates based around an existing key management system. So that's why I used to say keyless, because in Sigstore that's what it's called, keyless, if you don't manage the keys. But now I just say key automation because it's really, there are keys, customers get a little anxiety about that. Then Kubernetes. So Kubernetes is signing every release now with Sigstore. So you can, there's a script on the Kubernetes release page. You can go down, you can verify every container image, you can verify the binaries if you want to generate things yourself. Kyberno, is anyone using Kyberno at all, by any chance? It's an open source policy machine, and it plugs in with Sigstore to verify the images that they're signed when they go to get deployed. And then Gatekeeper is another policy engine that we're using, or that has a lot of heavy use and we've integrated with. Has anyone heard of Git Sign? So Git Sign is a project we're behind. It's incredibly easy to sign your Git commits with it, and that's really the purpose behind it. All you have to do is run basically run 4 commands inside your repo, and it turns on signing. And so when you actually go to do a Git commit, it'll sign it for you. So you'll see that machine, or you see that interface where it pops up. It asks you to log in with your email address, and then you'll sign those Git commits that are available through the browser. Now there was a really big announcement last month with GitHub and NPM.js. So the NPM.js community announced that they were going to be integrating Sigstore also, and they had to close some gaps in how you sign node modules. But also GitHub announced that they were going to provide a lot more support for Sigstore, not just integrate it. And so they're going to help staff the project to make sure things are up 24/7 for the public instance, and they're integrating this more heavily into their own environment and making it easy. But the real thing I thought was interesting was the quotes that came out of it from GitHub, where they basically said, we want something that's not going to slow down developers, right? That was very important to people. So easy win, sign your Git commits. So, and I'll show you why. Close out all my windows. Show you something interesting. My personal repo, and let's use this one because it doesn't matter. Any repo is good. Now, I want to show you how easy it is to impersonate someone else on GitHub. So I'm going to clone this repo, okay, go in, and right now there's actually GitHub does 0 verification that you are who you say you are. So for instance, I'm going to open up my Git config, and I'm going to say that I'm Dan Lawrence, he's the CEO of ChainGuard. And you'll see how easy this is and why this is important. Can everyone see this? Am I zoomed in enough?
Yeah.
Okay. So all I'm doing here is changing my Git config to be Dan's. I think it was. And I can say I'm anyone here. Let's see. If the matches, so if this matches his public email address associated with his account, it'll show up, this commit will show up as him. So if I do touch, text, and then I commit this, adding this demo file. So I come back here, and there he is. He just made a commit to my repo. Now where this gets really dangerous is pull requests. So if I wanted to do something malicious, first of all, this gives me, by having Dan someone that's really high profile in open source, make it look like they're appearing to my repo. I might be a bad actor, but a lot of people will just look at that and it'll give them validation, right? It'll validate me, right, through association, because these are really high profile people. I could add, anyone I wanted on here as potential, right? And then even further, it says that this person's a contributor to my project, right? So if someone comes on here, they're gonna think I'm very credible. I'm working with all these credible people, right? And where this gets really damaging is pull requests. So one of the big flurries that happened a couple weeks ago was basically there was a bot, it was cloning repos, makes malicious commits. I can make malicious commits that look like they came from somebody else, and then I send a pull request. Well, the only way to validate a Git signature is to sign your Git commit, but historically the adoption's been very low, right? So it's not standardized that people are only going to accept pull requests from users that have that haven't signed their Git commits, right? So this could potentially be really damaging. Now, if I wanted to check this, I can come in and I could say, well, he didn't sign it, so maybe we go back and we tell him to sign it. But I could sign it. You can see what happens there. So I want to show you how easy this is. Whenever I do a Git sign, I always install from scratch because it's just that easy to do this. So any repo, all I need to do is run this one command once to install the binary. And then after that, all I have to do is add these files in here, which will just change my Git config. That's it. So I did nothing. Perhaps this is just how easy it is. I can also set this as a global setting if I want to. And then when I go to sign it, it'll be clearly obvious that I am who I say I am, which is really key. And we're also working on, with GitHub, validating and checking a SIG store. So that was part of the updates. When you see this and I sign it, right now it'll say I'm unverified. It'll say the SIG store information, but it'll still say unverified. But you can later go in and change that. Or you can, soon there'll be an announcement, and I think that'll show up as a green checkbox, because right now it says unvalidated. So let's see. I'll come back to that in a second. We'll have to now. Okay. So a couple of things, other integration points is GitHub OIDC. So if you come back to what I was doing here, right? So this was one of the files I was showing you earlier, where we're using KO to do cosign. When I sign here, you'll notice there's no key, right? So where is that key coming from? Well, just like how I logged in using my Google address, GitHub added an integration with OIDC, so this GitHub action actually signs it with its own identity. It has its own identity, its own key management behind the scenes, and that's really critical for things like verifying that things came and were deployed, shipped as code. So that's a really important integration. Then Salsa, of course, there's lots of pieces there using a number of things. Salsa is basically a framework to do some of those attestation pieces that I was talking about. Mostly they look at the provenance, which again is the build, how the metadata about how you build your software. And then package repos, so these are all the application dependencies. So Python was just added, Ruby got added recently. Almost every single language or framework, even things like eBPF, you talk to the Linux kernel, a number of different things either are signing their software now with SIGSTOR or have plans to. A lot of the benefit is really in the plugins for your own languages too, so you can sign your own software very easily. So we work with a lot of customers that do, Gradle or Maven. There's plugins for all that stuff out there. So adoption's been very big. I think that's probably pretty clear by now. One real cool thing I wanted to point out was that there is a free course that we announced through the Linux Foundation. So if you're going in, you're doing like your Kubernetes training or what have you, do the SIGSTOR one while you're in there. I did my CK, CKD, CKA, and all that stuff, and those were really good courses. And if you do the SIGSTOR one in there, it is free, so you can't take it multiple times. I also put a blog in here to be part of the slides, and so it's really also about incremental adoption. It'll show you even if you want to reuse your existing keys, what that'll look like. So I've got just one minute of time. I just want to show you what this looks like real quick. So I'll change back to who I was earlier, because I don't want to be Dan anymore. Because all it's doing is looking at that email address. And honestly, I'll forget to do this later. So change it back to me, and then Git Sign is done now. So all I have to do is run a date, type that to a file, and then I'm going to have to sign this. And that's when I pulled it up. So I'll get another certificate, will be good for 10 minutes. And I will sign up my work again. And once I go to push that, let's go check that out. So you see here, did a commit. It says unverified. They're going to change that, but I can still see the signature in here was SIG-store signature. So signed by SIG-store.dev was the CA, and if I, let's see, where was I? Yeah, right there. And if I scrolled up, it had the log entry also. So if I want to go look through the browser again for that, all that will be there too. So sign your Git commits, that's very easy. Just a few lines of code to your repo. Start verifying your software. Those are the easy wins. There's a really cool script on the Kubernetes release page around verifying all the container images that come with Kubernetes and the code if you run your own. And a lot of distros too, like EKS, I think the Red Hat team, they're big users to SIG-store, so you get to sign if you're using a distro also. Make sure to sign those too. So and check out the free course. So I'm out of time here, but thank you. And yeah, I'll be here, so just let me know if you have any other questions. You got a question?
Yeah, so you guys have the update store integration as well, or like the implementation of the framework, or no?
Yeah, so SIG-store uses Tough for the root certificate. So it's interesting, they actually did a YouTube video last year. So there's 5 people walking around in the SIG-store community with UB keys, and you need 3 of them to rotate the root certificate. And so like one of them's at the University of Purdue, someone's at Google, someone's at ChainGuard, someone's at Red Hat. I think someone else works for some startup, maybe the Linux Foundation. But you need 3 of these people to get together if you want to rotate the root certificate for the public instance of SIG-store. Of course, you can run SIG-store on-prem. It's not very heavyweight. It is easier to use than run yourself, at least production-wise. So there's a refactoring group right now that work on some of that stuff also. But there's also workarounds, like you can set flags if you don't want certain things to go into the public transparency log. So there's kind of like a halfway point where you don't necessarily need to run your own transparency log. You can use it but not put anything sensitive in there. And if you want to run on-prem, that's perfectly valid also to not use the public instance. So there is like a lot of work being done. Like I always tell people in the software and supply chain space that are interested in it, like and that's why the theme for my deck is easy wins, because nothing's like fully baked yet. Like if you've been using SBOMs, they're not fully baked yet, right? So like the idea of SBOMs, they're gonna have all your transitive dependencies, they're gonna have your REST service that you point to, right? But today, they probably have your first line dependencies and that's it, right? So, and then how do you operationalize SBOMs? Still, some tools are starting to incorporate that you might already be using, but is it smooth? Is it still, there's still lots of things there, like every little aspect to it is there. So focusing on the easy things, not going off the beaten path is good. There's a lot of low-hanging fruit that you can do now just by verifying things that already exist. You can go to the release pages, they tell you how to They tell you how to verify things, and then just using the existing tools, right? So if you're using Docker, output that, build information, sign that. If you're using Podman, sign that. Some of the tools are better than others, but all the information, all the tools have to do something, right? So it's best to use that. You don't have to do anything new, and then you can just sign things as you go, and use your existing keys if you want to. It's all there. It's really the automation is the important aspect to it.
So I've been trying to do something similar on one of my projects where we try to do sort of attestations. And it looks like you guys are leaning a lot onto OIDC as part of the workflow, which is interesting to me. I've been trying to use more like PIV or CAC signature stuff, which is not so developed.
Yeah.
And so is that your guidance? Do you think like really some type of OIDC? Because I'm not always in a connected environment. So.
Yeah, so like someone did a write-up recently on like PIVs and like the smart cards, and like basically like they use like this kind of like 20-year-old Java extension hack that's no longer maintained to reach back to the device. So if anyone, basically like the write-up was saying, any website you go to, if they embed JavaScript, they could potentially access your smart card because there's no block. It's all available through JavaScript, right? And there's really not a lot of built-in JavaScript security, right? So if you have like an active reader, you get your card in there, and you sign things, you want to sign things that way, just be aware like, and there's always like the balance between what the intent of things are, right, and how it works. So, and that's something that will be in, your specific to your organization, how that plays out, right? There's a lot of things that have been just for checkbox reasons, right? But going forward, I do think this is more the way. Like if you look at a lot of cloud technology, like Kubernetes is a really good example. Kubernetes doesn't have any way to do curl checking or remote certificates, anything like that in it. It's really all about short-term certificates. And they're implicitly gone because they were only good for 10 minutes, right? So that's really, not that curl ever works that well anyway, but that's really more of a modern way, I think, to do it. And some of it doesn't come with the kind of legacy baggage of, for instance, like the JavaScript issue was just kind of one example of it. But I'm not sure how we would tie in. Probably best to use out-of-band cosign or use it, like if you were somewhere that had a smart card reader, try to tie in through OIDC or something else instead. Because every time I get really deep into like some of the federal PKI implementations, it's really messy. So it's there's a lot of, they got 5 ways they're integrated, they got 3 outputs depending on who you talk to, so it's all that stuff. And I was joking with Mark, like I think it was last year on Twitter. I said, like, I'll donate $100 to your charity of your choice if someone can explain to me, like, the PKI interoperability, like the federal PKI interoperability thing. And, it's on the DoD PKI page, and it's just how 1,000 different intermediate CAs talk to each other. And nobody could answer it for me. So, yeah, just simplicity, tends to win out, I think, long term.
Yeah.
I'm curious how long until we get rid of the experimental flag on this stuff? Everything says experimental.
So we're expecting that to be in about a month. So cosign is already GA. It's really the keyless piece of it. So the keyless, when I put in cosign, if you remember, it threw an error when I first typed in the command, right? And that's because I didn't have the cosign experimental flag set. So that turns on keyless mode, which was, reach out to Google or GitHub or whatever to get your ID. Before I turned on that, I was asking for a key. Those things are supposed to, like Recore and Pulsio for keyless support, is supposed to go GA like very soon. I can't guarantee a date, but I think would be definitely in the next 60 days for sure. And that's kind of at least what we're expecting. So. But there's a lot of other players. ChainGuard's big on the project, but the community's a lot bigger than just ChainGuard too, so can't really say for sure.